All right. Hey, everybody. So today, just a quick overview of presentation expectations for this phase 4 project presentation that is happening on Friday. For any reason, if you're not able to make that Friday presentation, please let me know. But I would love to have everyone get those presentations out of the way on Friday, just because, again, capstones begin next week. So I don't want everything to pile up. Oh, actually, one more announcement regarding capstones. With regards to blogs, you do need 4 blogs to graduate. So I am still waiting on the 3rd blog from some of you. But for the last blog, it doesn't have to be done after this project. So your last blog can also come after your capstone. Up to you to decide when you want to do that or what you want to write your blog on. Most people actually find it more helpful to write the blog, not on the phase 4 project, but on the capstone, just because there's more to talk about. So in terms of the blog that's coming up, that will be around the capstone time. So unless you want to knock that out with phase 4, you can do that too. I'll leave that up to you guys, but you do need 4 blogs submitted in order to graduate. So keep in mind. Okay, so in terms of presentations, I think similar to last time, I'm going to go over topic by topic, what the expectations are, the main things to talk about with regards to your presentation. So first I want to start a time series. There are a couple time series projects here. So first, regardless of which data set you're doing, whether it is the zip code data set or you have chosen your own time series data to do this on, set up your business case. And with time series, a business case is typically around your ability to forecast or to predict. So set up that business case, come up with the audience who is going to end up using your predictive or forecasting model, mention that at the very start. Now, in terms of EDA, the EDA is a little bit different from what we've been doing the last couple of projects, right? The last couple of projects with regression, it is very tied to the linear relationships and their assumptions for linear regression. And for classification, is very comparative. Now, for time series, the EDA can look slightly different. And there are a couple ways that you can approach the EDA for a time series project. So first and foremost, thinking about the typical like PACF, ACF. If you think about those two, those are fairly technical EDAs or technical visualizations. So it's really up to you to think about who your audience is for this presentation and whether that would be an appropriate visualization to include in your non-technical presentation. So most presentations, to be honest, I do not see the ACF or PACF. Unless, and I'll come back to this in a little bit, unless you are talking about your methodology in which you could show some examples of your ACF and PACF. But generally the EDA for time series is one, plotting the time series in general and showing and talking about some overall trends that you're seeing. If you're doing multiple zip codes or multiple time series, mention those as well. You could also do the seasonal decomposition. So if you remember the seasonal decomposition graphs, they give you 4 different graphs. They have seasonality, an overall trend, and any residual. That's actually a really neat one to talk about because those will be components that you do talk about or include in your modeling anyways. So in terms of EDA, I generally like to see the overall time series as well as maybe seasonal decomposition if you do think that there is seasonality in your data, especially. In terms of what else to include in this time series presentation, what this project looks like is really just throwing a lot of different models at your time series data. So an overview of your methodology would be very, very helpful because you're likely trying like a bunch of different ARIMA models, auto ARIMA possibly, maybe you try Facebook Profit as well, perhaps RNNs, but you definitely don't have to implement that for this project. But for that project, for that methodology section of your presentation, just mentioning real quick, what are the different models that you tried? And what tools you use to help you make decisions within that. So maybe you started with some PACF, ACF to give yourself a starting point for auto ARIMA, mention that you did that. And if you decide, okay, ARIMA is not doing good enough, let's try Facebook Profit to see if it improves or not, mention that as well. Typically a summary of results. And remember with time series modeling, but also any other machine learning modeling, you want to balance your model fit as well as your predictive power. So if you're doing the ARIMA models, don't forget you're looking at your AIC and BIC numbers. The smaller, the better. That's pretty much like your R squared for linear regression. It's a measure of how well your model fits the data. And then also your RMSE. RMSE, I would say, might be a little bit more important for forecasting because you want to see how well your model is able to forecast. So definitely include those. And then in terms of business recommendations, I'm going to go off here as well. Your recommendations for the provided data set obviously are what zip codes to invest in, but it's very important to address caveats. Now, while I was going over the time series material, one thing that I did mention a couple times is that those traditional ARIMA models are linear models. And so there are a lot of limitations to treating your time series data as linear. And so it's very important to mention that. In some of the graphs that you can plot for time series data, you can actually get these error bars or confidence intervals. You can adjust that too. Let's say you see one zip code going up a lot and one that goes up not as much, but maybe the confidence interval or the margin of error for the one that goes up a lot is a lot greater. So it's in the end a little bit more risky because of the amount of variance that it can take. You do want to mention that as well. So it's not always as straightforward as, okay, this one goes up the most, we're choosing that one. Perhaps also the one that has the least amount of error. So in terms of that time series project, it's very, very important to address the caveats. Maybe you can give a couple of recommendations based on who's more risk averse or who's more risk tolerant. Are those the same? No, those are opposites. Risk averse versus risk tolerance. Maybe you can give different recommendations based on the two different risk profiles. That's something you can do as well. Nice. Any questions with regards to the time series project? Okay. So next with the NLP project, I know at least those of you who have messaged me that are not doing the provided data set, you're also doing classification, so that's good. In terms of your business case, it's very important to think about this. I think everyone is doing some form of sentiment analysis, and depending on your business case, sometimes it's better to detect positive over negative, negative over positive. Which one is more important to your business case for you to be able to predict? So in coming up with that business case, it is very helpful to set up your metrics with that context. So for example, with the provided data set, you're talking about South by Southwest sentiment analysis on the tweets, right? So maybe you are a market researcher and you want to find out what are the things about different products that people don't like. Now, based on that business case, you want your recall for the negative class to be higher. And overall accuracy, especially if your data set is imbalanced, and overall accuracy can be very, very misleading because of your imbalanced data. So very, very important to keep that in mind. For NLP, dependent on what your approach is to this problem, you do want to lay out your methodology as well, because the way you vectorize your data can sometimes really impact the result of your classification. So therefore, one, make sure it's comparative. And by the way, with the last project, because everything was you didn't have as many columns, but also once you vectorize your text, you end up with a lot of columns. It's a lot harder to do comparative EDA. That definitely is true. So when you're doing your comparative EDA, perhaps draw this from like your feature importances or your coefficient analysis. Do that comparative EDA on the important words after your modeling, so that you're not doing like a comparative EDA on every single word. Something that's off topic from presentations. Since I see that there's a few of you here who are working on the NLP project, as you're going through your vectorizer, let me pull up TF-IDF real quick for this segue. If you're seeing high matrix sparsity, or if you're seeing just like that you have a lot of columns and it's really slowing down your performance, one thing that you can do, and I did mention this before, but really in passing, one thing you want to look for is max features. So here, let's just say you have like 80,000 unique words. You don't want to use all 80,000 in your modeling. Maybe you want to cut it down to like the most popular 10,000. Use the max features argument in your vectorizer, because that's going to save your computer a lot of processing power. And also you'll just have you just won't have as much noise in your data. Like you won't have like the words that have only appeared like once or twice being considered in your model. And once or twice in like your entire data set too. So definitely check out max features, especially if you find that your models are taking a long time to run, or if you feel like you don't need to use like all like 100,000 words that are being included in your data frame.
So we would put like max features equals to a number, right?
That's right.
And then that number is going to be reflective of the most prominent words automatically, or do we have to?
Correct. So it will automatically do it ordered by term frequency across the corpus. So basically, yeah, that's right. It's by the occurrences throughout your entire data set. So it will not keep words that have only appeared like one time ever, like maybe a typo of a word will not be considered, which is what you want anyways.
Thank you.
You're welcome. All right, so that was a quick segue. Now, in terms of the EDA for your text data that you want to show during your presentation, word clouds are usually the most preferred one because it's very, very visually appealing and it's eye-catching and it's like easy to interpret, especially because you don't have to get into the nitty-gritty of like exactly how many times a word has appeared. So typically word clouds are good enough just to show the overall what are most used words per class. Oh, by the way, if you're doing it comparative, which you all are, you should have a word cloud per category, just so you can see if there are any differences between the most prominent words within each category. Now, another really good EDA tool, which I did talk about, but not too in depth when we went through NLP a couple weeks ago, is using LDA. LDA, if you're looking for the code for that, it is in the NLP notebook. So I think it is under NLP Advanced, which is not over here, but I have to go into my study groups notebook. So if you're looking for that LDA graph, which is actually topic modeling, it will help you draw out what the main topics are using a bit of word embeddings. The code is in the deeper NLP notebook over here. It's not run. This will take a little while to run because it is doing soft clustering on your entire data set, or you can also do this per class, by the way. This is actually a really, really cool EDA, but it's definitely not necessary for this project because it does take a little bit of work setting up. So would be good if you can for this project, but if not, save it for your NLP capstone. Cool. When you get to your modeling component, again, describe your methodology. Did you try different vectorization techniques? What were the different models that you tried? Perhaps you have a model summary slide, or maybe you just want to compare your final model to a baseline model. We want to see some results and call back the metric that you decide to focus on. Again, very similar to the last project, classification report and confusion matrix will be helpful in visualizing those results. And then based off of that, especially if you use a tree model, get your feature importances, because then you can make very definitive conclusions, being like, okay, if I see the word or the bigram Google circles used, it's definitely going to be negative, and that can be actually turned into a recommendation as well. When you have so many features, so let's say you end up doing like 1,000 features for your model, you do have to look at more than just the top few, especially because it's words. Sometimes it's obvious, sometimes it's not. So based on what your feature importances are, maybe it's obvious to see which ones are positive, negative, but remember that feature importances don't immediately tell you which direction it goes. So you want to do a little bit more digging, perhaps some additional EDA on the specific word to see like how often they are used within each category to then make your more quantitative conclusion. Cool. So yeah, this is how you can draw your recommendations for your models, what words led to classifying your sentiment as positive or negative. And again, based on your business case, how can the companies adapt with this model to better serve their customers? This is just an example of a business case. Cool. Any questions about this NLP component? All right. Okay, so finally, image classification, which I think is the least straightforward one for a presentation. So with the business case, for image classification is usually pretty obvious. And for this one, if you're doing the provided data set, which I think everyone is doing, is really just detecting pneumonia. I mean, the business case is very, very straightforward. But could you go deeper than that? Maybe you want to look up, and I think this number here somewhere is how accurate are doctors themselves at detecting pneumonia through looking at an X-ray, and maybe comparing that or using that as a baseline could be very interesting. So definitely start with that business case. EDA for images, very, very difficult. So maybe just do a summary, maybe just show your class balance and a couple examples of images with pneumonia, without pneumonia, and that will be enough for EDA. In terms of the modeling and how you go over that methodology, just talk briefly about what are the different modeling techniques that you tried. Maybe you start with a dense model first, followed by a CNN model. Maybe you did some hyperparameter tuning to finally arrive at your final model, and that's it. I've seen some presentations that actually put like the model summary architecture, which is really not necessary because for a non-technical audience, those numbers don't really make sense. Maybe you want to throw in the fact that, okay, altogether your model was looking at like 20 million parameters. You could mention that offhand to just talk about or to just, slip in like the complexity of a neural network. But I think I would say that that's probably the most you want to get into in terms of like the technicality of the neural network. In terms of the recommendations can be a lot more qualitative or general. Were you able to increase performance from some baseline number, and what were the things that you think improved your performance from that baseline? Also, for recommendations, I feel like for this project, you can kind of weave in your future work as well. You can make recommendations on your model architecture. Maybe you didn't have time to incorporate as many CNN layers as you would have liked. Maybe you had your accuracy hovering above around a certain number that you couldn't get any better, but didn't have the chance to incorporate things like pre-trained networks or just additional layers. You could mention that as well. Also, something that would be really cool, I think, but not necessary as well. I will say this, if you're doing a neural network capstone, I will ask for this. But there's a library that you can overlay a heat map to find out the most important pixels per each image. That is basically visualizing the activation functions and what is being fired. I keep forgetting to link that library, so I'll do that right after this. But that library, you can basically feed it in your network and it'll show you which part of an image the network is focusing on. So for example, if you're doing pneumonia and not pneumonia, via the x-rays, pneumonia is basically, or you can typically see pneumonia based on some cloudy areas in a chest x-ray. So you can actually get a heat map that will identify those areas. And I'll look for that library to send it out and I'll link it here and I'll send it to the Slack channel as well. But yeah, this presentation, because the model is so complex and uninterpretable, the recommendations just are less drawn from the model as a result. So the recommendations should be more about architecture and more about how, with your business case, this model could be used by someone else. But yeah, those are my overview for presentations for these projects. Any questions about presentations for now? I know it's coming in 2 days, and I know most of y'all started the project only yesterday or today. So yeah, it's going to be a very quick turnaround for this project. But yeah, any questions at this point before I stop the recording and we can talk about other things? Sweet. All right.